In question number 1, the coefficients of x and x square in the expansion of 2 plus ax power 7 are equal. We have to find the value of the non-zero constant a. Now, when there's an expression of the form a plus b to the power n, we expand it using the formula a to the power n plus nc1 a power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2 and so on. As we just need the coefficients of x and x square, and as in this expression, in place of b, we have ax. So we can use nc1 and nc2 to find the coefficients of x power 1 and x power 2. So writing 7c1, a is 2, so that will become 7 minus 1 b to the power, so that will become ax to the power 1 plus 7c2 2 to the power 7 minus 2 and ax to the power 2. So 7c1 is 7, so that will become 7 times 2 to the power 6. So 2 to the power 6 is equals to 64, so that will become 7 into 64 ax, and that is equal to the coefficient of x squared. So 7c2 is 21, so that will be 21 times 2 to the power 5, which is 32, a squared x squared. Now, as these coefficients of x squared and x are equal, so we can write 7 times 64a will be equals to 21 times 32a squared. Now, to find the value of a will come and divide over here, so this will cancel out. So a will be equals to, so 7 into 64 will divide by 21 into 32. So this will cancel with 32 and 64, so that will become 2, and this will become 7 one time and 7 three times. So the value of a will be equals to 2 upon 3. Question 2, the common ratio of a geometric progression is r. The first term of the progression is r squared minus 3r plus 2, and the sum to infinity is s. In part 1, we have to show that s equals to 2 minus r. Now, we know that the formula for sum to infinity is given by a divided by 1 minus r. So in this question, a is given as r squared minus 3r plus 2 divided by, so this will be divided by 1 minus r. Now, factorizing r squared minus 3r plus 2, so that will become, when we middle term break it, that will become minus 2r minus r plus 2, and this is being divided by 1 minus r. Taking common, this will become r into r minus 2, and taking 1 common, this will become r minus 2 upon 1 minus r. Simplifying, the sum to infinity will become r minus 1 and r minus 2 divided by 1 minus r. Now, r minus 1 and 1 minus r, if we simplify it, so to understand this will become a minus 1. So let's say if we take any number, let's say this is, if you have r minus 1 upon 1 minus r, so if you have 10 minus 1 divided by 1 minus 10, this will always be equals to minus 1, as this will become 9 upon minus 9, or we can take any example, it could be 8 minus 1 divided by 1 minus 8. So this will become 7 upon minus 7, so this will always be minus 1. So if we cancel out r and 1 minus r, this will be equals to minus 1. So sum to infinity will be equals to minus 1 into r minus 2. So minus 1 into r will become a minus r. And as we had to show in the expression, it is 2 minus r. So minus 1 into minus 2 is plus 2. So this will become 2 minus r. In part 2, it says find the set of possible values that s can take. Now, a sum to infinity is when the common ratio is greater than minus 1 and less than 1. So in the first step, as the sum to infinity is equals to, as s is equals to 2 minus r, we can take the value of r as minus 1. So 2 minus minus 1 will become 3, and taking r equals to 1, so that will be equals to 1. So the sum to infinity, the values of s will be greater than 1 and less than 3. Question 3, we have to find the coordinates of the points of intersection of the curve y equals to x power 2 upon 3 minus 1 with the curve y equals to x power 1 upon 3 plus 1. Now, to find the coordinates of the points of intersection, we solve the equation simultaneously. So we can write the first equation, x to the power 2 upon 3 minus 1, as equals to x to the power 1 upon 3 plus 1. Bringing x to the power 1 upon 3 on the left hand side, so we can write it as x to the power 2 upon 3 minus x to the power 1 upon 3 minus 1 equals to 0. Now, we can use a substitution over here to make the equation simple for us. So let's say if we take x to the power 1 upon 3 as equals to y. So x to the power 2 upon 3, which we can write as x to the power 1 upon 3 whole squared, can be written as y squared. So writing this equation as y squared, and this will become minus y minus 2 equals to 0. Factorizing this, we'll get y squared minus 2y plus y minus 2 equals to 0. Taking y common, we'll get y minus 2, and taking 1 common, this will become y minus 2 equals to 0. So this will become y plus 1 and y minus 2 equals to 0. So the values of y will be y equals to 2 and y equals to minus 1. So once we have the values of y, we know that y is equals to the cube root of x. So this is, we can write it as x to the power 1 upon 3 as cube root of x. So one of the values of y will be cube root of minus 1, which will be equals to minus 1, and y will be equals to, so this will become, okay, so one correction, we have the values of y, not the values of x, so we have to find the values of x. So in the first case, the value of y is 2, so we can write it as x to the power 1 upon 3 is equals to 2. Now to find x, we can whole cube both the sides. So x will be equals to 8, and the other value of x will be as x power 1 upon 3 will be equals to minus 1. So taking the cube on both the sides, so x will be equals to minus 1. So the two values of x are minus 1 and 8. Now, once we have the x value as minus 1 and 8, to find the y coordinates, we can use either of the two equations. So using this equation, y equals to x to the power 2 upon 3 minus 1. Substituting x equals to minus 1, we'll get minus 1 to the power 2 upon 3 minus 1. So that will become y. So this cube root of 1 will become minus 1, and minus 1 whole squared will become plus 1. So this will become 1 minus 1. The y coordinate will be equals to 0. So one of the points of intersection will be minus 1 comma 0. And now taking x equals to 8. So that will become y is equals to 8 to the power 2 upon 3 minus 1. Cube root of 8 is 2. 2 squared is 4. And 4 minus 1 will become 3. So the other point of intersection will be 8 comma 3. Question 5, part 1, we have to show that the equation 2 sine plus cos upon sine plus cos equals to 2 tan may be expressed as cos square equals to 2 sine squared. So in the first step, to prove, we can write it as 2 sine plus cos upon sine plus cos. And we know that the identity for tan is sine upon cos. So we can write 2 into sine upon cos. Cross multiplying, we'll get 2 sine cos plus cos squared is equals to, so 2 sine will multiply by sine. This will become 2 sine squared. And this will become 2 sine into cos will become a 2 sine cos. So 2 sine cos on both the sides are of the same sign, so they will cancel out. So we'll be left with cos squared theta will be equals to 2 sine squared theta. In part 2, it says, hence solve the equation for 0 to 180. Now we know that this can be written as cos squared theta is equals to sine squared 2 sine squared theta. So this is cos squared theta is equals to 2 sine squared theta. Bringing the cos square on the right hand side and 2 on the left hand side, we can write this as 1 upon 2 is equals to sine squared theta upon cos squared theta. So we know that sine squared upon cos squared is tan squared. So this will be tan squared theta is equals to 1 upon 2, or tan theta will be equals to square root of 1 upon 2. Now to find theta, we'll first, or to find the basic angle first, we'll do tan inverse of square root of 1 upon 2. Now this square root of 1 upon 2 basically implies that we can have both angles in the positive and the negative quadrants of tan. And as the domain or theta values are from 0 to 180, so tan is positive in the first quadrant and it is negative in the second quadrant, but as it is a square root sign, so we'll be making the basic angle in both of these quadrants. So now taking tan inverse of 1 upon 2. So it's taking shift tan inverse of square root of 1 upon 2. That is equals to 35.26 degrees. Now we'll make the basic angle in the first quadrant 35.26 and in the second quadrant as well, which is 35.26. To find theta, we'll measure angles anti-clockwise from the positive x-axis. So the first angle will be 35.26. So theta will be equal to 35.26 degrees, and the second value of theta will be, so this value will be 180 minus 35.26. So 180 minus 35.26, that is equals to 144.74 degrees. And as we have to give our angles to one decimal place, so the final answer will be 35.3 degrees and theta will be equals to 144.7 degrees. In question 6, the line 3y plus x equals to 5 is a normal to the curve y equals to x square minus 5x plus k. We have to find the value of the constant k. Now this the line which is the normal has the equation 3y is equals to, we can write it as minus x plus 25, or we can make y the subject and write it as minus 1 upon 3x plus 25 upon 3. Now let's say we have a curve over here and this is a normal over here. Now this normal has a gradient of minus 1 upon 3. This is the gradient of the normal. From the equation, we can take it as y equals to mx plus c. So the gradient will be minus 1 upon 3, which means that the gradient of the tangent over here, as this gradient is minus 1 upon 3, the gradient of the tangent will be equals to positive 3. So if you find the dy dx of the curve, which gives us the gradient of the tangent, so the dy dx will be equals to, that will become 2x minus 5. Now the dy dx is equals to positive 3. So we can write it as 3 is equals to 2x minus 5. So this will become 2x is equals to 8 and x will be equals to positive 4. Once we have the value of x as 4, to find the value of the constant k, we can substitute this into the equation of the line. So the y coordinate will be equals to, now to find the value of k, we need to make a quadratic equation, and then we can use the discriminant or substitute the x and the y values over here to find the value of k. So as we already have the x value, using the equation of the normal, we can find the y value and then substitute it over here to find the value of k. So the equation of the line is 3y plus x is equals to 25. So x is 4, so this will become 3y plus 4 is equals to 25. So 3y will be equals to 21 and y will be equals to positive 7. Now once we have the value of y and x, as this is the point where the curve and the normal are intersecting, which is 4, 7. So we can substitute this in the equation of the curve, which is y square is equals to x square minus 5x plus k. So substituting y equals to 7, this will become 7 squared is equals to the value of x is 4. So this will become 4 squared minus 5 into 4 plus k. So 7 squared is 49. This will become 16 minus 20 plus k. So this will become 49 is equals to minus 4 plus k. So 4 will go on the left hand side, and so there is a small problem. This is y is equals to x square minus 5x plus k. So this is not y squared, this is just y equals to 7. So there's a small correction over here. This will be just y equals to 7 up here. So this will become 7 is equals to 4 squared minus 5 into 4 plus k. So 7 is equals to 16 minus 20 plus k. 16 minus 20 is minus 4. 4 will go on the left hand side, minus 4. So that will become a plus 4. So k will be equals to 7 plus 4. So the value of k will be equals to 11. Question 7, the diagram shows two circles with centers A and B having radii 8 centimeter and 10 centimeter respectively. The two circles intersect at C and D, where CAD is a straight line and AB is perpendicular to CD. In part 1, we have to find angle ABC in radians. Now, as this is a right angle triangle, to find this angle, let's call this angle theta. We can use opposite over hypotenuse, which is sine. So sine theta will be equals to opposite, which is 8 upon hypotenuse 10. So theta will be equals to sine inverse of 8 upon 10. We have to make sure the calculator should be in radian mode, as we are as the angle in it is asking the angle in radians. So first making the calculator in radian mode and finding sine inverse of 8 divided by 10, that is equals to 0.92729 radians. So we can give it to three significant figures as 0.927. In part 2, we have to find the area of the shaded region. Now to find the area of the shaded region, first we can make a sector from B to, first make a line from B to D. So to find the area of the shaded region, first we can find the area of the sector BCD. We can find the area of both of these triangles. As this is 10, this is 8, we can apply Pythagoras theorem to find the height AB. Once we have these two areas, we can subtract the area of the triangle from the sector to get this area of the segment, which is from C till D. And as the center of the smaller circle is A, we can find the area of the semicircle and subtract this area to get the area of the shaded region. So starting with the area of the sector, which is BCD. So area of sector BCD will be equals to half r squared theta. So we know that the radius of the bigger circle is 10. So that will become half into 10 squared into 0.927. So 10 squared, that will become 10 squared multiplied by 0.927. And then dividing this answer by 2. So the area of the sector will be equals to 46.35. Now finding the area of the, now finding the area of this triangle ABC. So area of triangle ABC, we can apply half base into height. So as this length is 10 and this is 8, applying Pythagoras theorem, we can find the length of AB, which is the height. So AB squared will be equals to 10 squared minus 8 squared, which is equals to 36. The square root of 36 will be equals to 6. So AB will be equals to 6. Now the area of ABC will be equals to half into 8 into 6. So this will become half into 8 into 3, which is equals to 24. So this will be equals to, as the one triangle is equals to 24, so the area of two triangles will be equals to 24 times 2. So we can write it as 24 times 2, which will be equals to 48 centimeters squared. And there's just one small correction over here. As we were finding the area of the sector, this angle was 0.927. So this angle will also be 0.927. So this area will not will be 2 times 0.927. So this answer will be 46.35 times 2. So the final answer will become 92.7 centimeters squared. Now, once we have the area of the triangle and the area of the sector, we can write that the area of segment, which is basically this part from C till D, will be equals to the area of the sector, which is 92.7 minus 48. So 92.7 minus 48, that is equals to 44.7 centimeters squared. Now finding the area of the semicircle with the circle with center A. So the radius is 8. We can write that the area of semicircle will be pi r squared upon 2. As the radius is 8, this will become pi into 8 squared. So this will become pi into 8 squared upon 2. So that will become 64 upon 2, which is equals to 32 pi. So the final answer for the area of the shaded region, as the area of the semicircle is 32 pi. So the area of the shaded region will be equals to 32 pi minus the area of the segment, which was 44.7 centimeters squared. So 32 times pi, that is equals to 100.53. So 100.530 minus 44.7. So minus 44.7, that is equals to 55.83 centimeters squared. As we have to give our answer to three significant figures, so the final answer will be 55.8 centimeters squared. In question number 8, point A is -1, 1 and P is A, B are 2 points. The gradient of AP is 2. We have to find an expression for B in terms of A. Now we know that the formula for gradient is y2 minus y1 upon x2 minus x1. So as the gradient is 2, we can write this as B minus 1, which is y2 minus y1 divided by x2, which is A minus minus 1. So this will become A plus 1. We can write it as 2 is equals to B minus 1 upon A plus 1. As we have to give our expression for B in terms of A, so cross multiplying, we'll get 2A plus 2 is equals to B minus 1. Taking 1 on the left hand side, so that will become 2A plus 2 plus 1 is equals to B. So we can write B will be equals to 2A plus 3. In part B, it says that B is equals to 10, minus 1 is a third point such that AP is equals to AB. We have to calculate the coordinates of the possible positions of P. Now, the length of AP and AB are equal. The coordinates of A are minus 1, 1. The coordinates of P are A, B, and the coordinates of B are 10, minus 1. So first finding an expression for the distance AB. So that will become, we know that the distance formula is square root of x2 minus x1. So that will be B minus 1 whole squared plus A minus minus 1 whole squared. So that will become A plus 1 whole squared. And then equaling it to the distance of AB. So that will become minus 1 whole squared plus that will become 10 minus minus 1 whole squared. So that will become a 10 plus 1. Now we know from the previous expression that B is equals to 2A plus 3. So in place of B, we can write 2A plus 3 and we can cancel out the square roots, as if we whole square both the sides, the square roots will cancel out. And in place of B, we can write 2A plus 3. Expanding this, we'll get, so before expanding, we can simplify the expression. This will become minus 1 whole squared is 4 and 2 squared will become 4 and this will be 11 squared, which will be equals to 121. So this will become 2A plus 2 whole squared plus A plus 1 whole squared is equals to 125. That will become 4A squared plus 8A plus 4. Expanding A plus 1, that will become A squared plus 2A plus 1 is equals to 125. Simplifying this, we'll get 4A squared plus A squared, which is 5A squared. 8A plus 2A is equals to 10A. 4 plus 1 is 5. And bringing 125 on the right-hand side, we'll get minus 125 equals to 0. So simplifying this, we'll get 5A squared plus 10A minus 120 equals to 0. To factorize this, we can divide the whole expression by 5 and that this can be written as A squared plus 2A minus 24 equals to 0. Applying middle term breaking, factorizing this expression, so that will become, we'll need the two factors which will be plus 6 and minus 4. So this will become A plus 6 and A minus 4 equals to 0. So the two values of A will be equals to positive 4 and A will be equals to minus 6. Once we have these values of A, to find the value of B, we know that B is equals to 2A plus 3. So as B is equals to 2A plus 3, applying A as 4, so that will become 4 times 2, 8. 8 plus 3 is 11. And in this case, A is equals to minus 6. So this will become minus 12 plus 3. Minus 12 plus 3 is minus 9. So the possible coordinates of P will be 4, 11, and this will be, the other will be minus 6, minus 9. In question number 9, part 1, we have to express 9x square minus 6x plus 6 in the form ax plus b whole squared plus c, where a, b, and c are constants. Now, in the first step, we can write this equation, which is 9x square minus 6x plus 6, and equate it to the expansion of this expression. So that will become a squared x squared plus 2ax plus b squared plus c. Now comparing the coefficients on the left and the right hand side, on the left hand side, that is 9, the coefficient of x squared, and on the right hand side it is a squared. So a squared will be equals to 9 and a will be equals to 3. The coefficient of x on the left hand side is -6, and on the right hand side that is 2a. So that will become 2abx. So this was 2abx over here. So the coefficient is 2ab. So 2ab will be equals to -6. The value of a is 3. So that will become 6b is equals to -6. So b will be equals to -6 divided by 6, which is -1. And the constant term on the left hand side is -6, and on the right hand side that will be equals to b squared plus c. So b squared plus c will be equals to -6. b is -1, so -1 whole squared is 1. So c will be equals to -6. So c will be equals to -6 minus 1. So that will be equals to -7. So there's a small correction over here. This is a +6 over here. So this will be +6 minus 1. So +6 minus 1 will be equals to +5. And this was 2abx over here. So this will be 2abx plus b squared plus c. So once we have the values of a, b, and c, we can write the expression as a is 3. So that will become 3x minus 1 whole squared, and the value of c is 5. So this will become 3x minus 1 whole squared plus 5. In part 2, it says the function f is defined by f of x is equals to 9x squared minus 6x plus 6 for x greater than equals to p. We have to state the smallest value of p for which f is a one-to-one function. Now we know that f of x can be written as 3x minus 1 whole squared plus 5. Now for it to be a one-to-one function, we know that if it is a quadratic curve, so let's first make a quadratic curve. And if we take 3 common out over here, so that will become 3 squared into x minus 1 upon 3 whole squared plus 5. So this will become 9 into x minus 1 upon 3 whole squared plus 5. The turning point will be at positive 1 upon 3 and positive 5. So let's say this is 1 upon 3 and this is 5. So the quadratic curve will be like this. And as it has to be a one-to-one function and x is greater than p, so the smallest possible value for which it will be a one-to-one function will be 1 upon 3. As we are going greater than this particular value, so the smallest possible value for x, which is basically p, will be equals to 1 upon 3. So we can write p will be equals to positive 1 upon 3. And this y value is 5 up here, the turning point. In part 3, it says for this value of p, obtain an expression for f inverse and state the domain of f inverse. Now, f of x was 3x minus 1 whole squared plus 5. To find f inverse, we'll first write y is equals to 3x minus 1 whole squared plus 5. Now, exchanging the values of x and y, that will become x is equals to 3y minus 1 whole squared plus 5. Taking 5 on the right hand side, that will become x minus 5 is equals to 3y minus 1 whole squared. Taking the square root on both the sides, so we can write this as square will cancel out, and this will become 3y minus 1 is equals to square root of x minus 5. Now, making y the subject, we'll take the one on the right hand side, that will be 3y is equals to square root of x minus 5 plus 1. And then finally dividing it by 3. So y will be equals to square root of x minus 5 upon 3 plus 1 upon 3. And we can write the expression for f inverse of x as square root of x minus 5 upon 3 plus 1 upon 3. Now, as we also have to state the domain of f inverse, we know that the domain of the inverse function is equals to the range of the original function. So the range of the original function was greater than equals to 5. So the domain for f inverse will be x will be greater than or equals to 5. In part 4, it says that state the values of x for which f of x is equals to q has no solutions. Now we know that f of x was So that was 3x minus 1 whole squared minus plus 5, and that is equals to q. We have to find the values of q for which it has no solutions. Now this quadratic function f of x was having the turning points, which were, this point was 1 upon 3 and this point was 5. So basically what we are trying to understand over here is that this q value is basically representing the y values. As we can write this as y is equals to 3x minus 1 whole squared plus 5. So this q value is representing the y values. So if we have any value less than 5 and we make a line, let's say if the value of q was 4 and we make 4 up here, there will be no points of intersection or no solutions. But any value 5 or greater, there will be solutions, as any value which is any value of q or the value of y which is more than 5 will be intersecting the curve. So the set of values of q for which f of x equals to q has no solutions, that will be q should be less than or equals to 5, not equals to, as if it is equal to 5 there will be one point of intersection, so q has to be less than 5. In question 10a, figure 1 shows part of the curve y equals to x square minus 1 and the line y equals to h, where h is a constant. In part 1, the shaded region is rotated through 360 degrees about the y-axis. We have to show that the volume of the revolution is given by v equals to pi into 1 upon h square plus h. Now, when we have to find the volume when the curve is rotated about the y-axis, we have to make sure that x is a subject. So the equation is y equals to x square minus 1. Making x the subject, this will become x square is equals to y plus 1. And taking the square root on both the sides, so x will be equals to y plus 1 to the power 1 upon 2, or the square root of y plus 1. Now, to find the volume, the formula for volume is given by pi into y squared, the integral of y squared, and the limits, and they will be in terms of y. So the limits we can see are y equals to h and y equals to 0. So to find the volume, we'll write pi into h and 0, and y squared will become y plus 1, 1 up to the power 1 upon 2, and we'll have to whole square this. So when we whole square, the 1 upon 2 and 2 will cancel out, so we'll get y plus 1. Now integrating y plus 1, we'll get, so integrating y, that becomes y squared upon 2, and integrating 1, that becomes y. Now substituting the limits, so when we substitute y equals to h, so that will become, the volume will be equals to, so pi will be a constant, this will become h square upon 2 plus, and this will be h. And when we substitute y equals to 0, so this will become 0 upon 2 plus 0, so that will be a 0. So the volume will be equals to pi multiplied by 1 upon 2 h square, or h square upon 2 plus h, as we had to prove in the question. In part 2, it says find, showing all the necessary working, the area of the shaded region when h is equals to 3. Now to find the area of the shaded region, we already have y in term x in terms of y, so x is equals to y plus 1 to the power 1 upon 2. To find the area, we'll integrate the expression for y, so the area will be integral of y plus 1 to the power 1 upon 2, and the limits will be 3 and 0. Now integrating y plus 1 to the power 1 upon 2, so we'll increase the power by 1. So 1 upon 2 plus 1 becomes 3 upon 2, and we'll divide by the new power, which is 3 upon 2. And we can write this as 2 upon 3 into y plus 1 to the power 3 upon 2. Now the upper limit is y equals to 3. So substituting y equals to 3 first, this will become 2 upon 3 into 3 plus 1 to the power 3 upon 2. And we'll subtract it from the lower limit, which is y equals to 0. So this will become 2 upon 3 into 0 plus 1 to the power 3 upon 2. So 3 plus 1 is 4. 4 square root is 2, and 2 cube is 8. So 8 times 2 will become 16 upon 3, minus 1 to the power 3 upon 2 will be 1. So this will become 16 upon 3 minus 2 upon 3. So the area of the shaded region will be equals to 14 upon 3. In part B, it says figure 2 shows the cross section of a bowl containing water. When the height of the water level is h centimeter, the volume of water is given by v equals to pi into half h square plus h. Water is poured into the bowl at a constant rate of 2 centimeter cube per second. This means that the rate of change of volume, or dV by dt, will be equals to 2. We have to find the rate at which the height of the water level is increasing. So it means we have to find dH by dt when the height of the water level is 3 centimeters. So the formula relating V and H, the rate of change formula will be dV by dt will be equals to dV by dH multiplied by dH by dt. So in the first step, we'll find dV by dH as V is equals to pi into 1 upon 2 h square plus h. So integrating, so differentiating 1 upon 2 h square. So 2 will multiply with the coefficient. So that will become 2 upon 2 h plus, and this will become 1. So 2 and 2 will cancel out. The value of h is 3. So this will become 3 plus 1, which will be equals to 4 pi. Now, once we have the value of dV by dH, so this is dV by dH. The value of dV by dH is 4 pi, and the value of dV by dt is 2. So this will be 2 is equals to 4 pi into dH by dt. So dH by dt will be equals to 2 divided by 4 pi. So the final value for dH by dt will be equals to 2 divided by 4 pi. Simplifying this, the final answer will become 1 upon 2 pi. We can leave this answer as it is or give it in a decimal form. Either ways, it will be marked correct. Question 11, the function f is defined for x greater than or equals to 0. It is given that f has a minimum value when x equals to 2 and that f double derivative of x is equals to 4x plus 1 to the power minus half. We have to find f dash of x, or basically this represents dy by dx. Now, as this is the double derivative, f dash double dash of x is 4x plus 1 to the power minus 1 upon 2. To find f dash of x, which is dy dx, we'll have to integrate the expression. So f dash of x will be equals to, so we'll increase the power by 1, so that will become 1 upon 2. We'll divide it by the new power, which is 1 upon 2 into 4, and we'll add a constant plus c. Now it says that the minimum value when x equals to 2 means that f dash of x will be 0 when x is equals to 2. So this will cancel out and become a 2, and we'll substitute x equals to 2 over here. So that will become 4 into 2 plus 1 to the power 1 upon 2 upon 2 plus c. So 8 plus 1, 9. Square root of 9 is 3. So this will be 0 is equals to 3 upon 2 plus c. So the value of c will be equals to minus 3 upon 2. Once we have the value of c, we can write that f dash of x will be equals to 4x plus 1 to the power 1 upon 2. This is dividing by 2, and the value of c is minus 3 upon 2. In part 2, it says it is now given that f double derivative of 0, comma f dash of 0 and f of 0 are the first 3 terms of an arithmetic progression. We have to find the value of f of 0. Now, as it is an arithmetic progression, it means that 3 consecutive terms have a common difference. Now, f double derivative of 0 will basically mean that in the expression for f double derivative, which is 4x plus 1 to the power minus 1 upon 2, we'll substitute x equals to 0. So this will become 1 to the power minus 1 upon 2. So that will be equals to 1. Finding f of 0, f dash of 0. So the expression was 4x plus 1 to the power 1 upon 2 divided by 2 minus 3 upon 2. Substituting x equals to 0. So that will become 1 upon 2 minus 3 upon 2, which is equals to minus 2 upon 2, or equals to minus 1. So when we find the difference between 2 consecutive terms, so f dash of 0 minus f double derivative of 0 will be equals to minus 1 minus 1. So the common difference is minus 2. It means that f of 0 will have a similar difference from f dash of 0. So the value for f of 0 will be equals to the value of f dash of 0, which is minus 1, and the common difference, which is minus 2. So minus 1 minus 2, which will be equals to minus 3. Now in part 3, it says find f of x and hence find the minimum value of f. Now to find f of x, we have the expression for f dash of x, which is 4x plus 1 to the power 1 upon 2 upon 2 minus 3 upon 2. Now to find the expression for f of x, we'll have to integrate this expression. So integrating f dash of x, that will become 4x plus 1 to the power, we'll increase the power by 1, so that will become 3 upon 2. we'll divide it by the, so 2 is already here, we'll divide it by the new power, which is 3 upon 2, and also multiply it with the derivative of 4x plus 1, which is 4. So 2 and 2 will cancel out. Integral of 3 upon 2 will become a 3 upon 2x, and we'll add a constant plus c. Now to find the value of c, we already know that when f of 0 is equals to -3, it means when x equals to 0, it will be equals to -3. So we can write -3 over here. In place of x, we'll substitute 0. So that will become 0 plus 1, which is 1 to the power 3 upon 2 upon, so this will become 12 minus 3 upon 2, and this will also multiply by, so x value is 0 plus c. So this will become -3, and 1 upon 12 will go on the left hand side and become a -1 upon 12, which is equals to c. So c will be equals to 12 times 3 is 36. So that will become -37 upon 12. Once we have the value of the constant c, so we can write the expression for f of x, which will be equals to 4x plus 1 to the power 3 upon 2 upon 12 minus 3 upon 2x, and the value of c is -37 upon 12. It also is asking us to find the minimum value of f. So for the minimum value of f, we already know that the x coordinate for the minimum value is 2. So to find the minimum value, so when x is 2, we have a minimum value. So that will be equals to, we'll substitute x equals to 2. So that will become 9 to the power 3 upon 2 upon 12 minus 3 upon 2 into 2 minus 37 upon 12. So 2 and 2 will cancel out. So square root of 9 is 3. 3 cube is 27. So this will become 27 upon 12 minus 3 minus 37 upon 12. We can first subtract 27 and 37. So that will become a minus 10 upon 12 minus 3. Taking the LCM, that will become minus 10 minus 36 upon 12, which will be equals to minus 46 upon 12. And simplifying this will become 23 upon 6. So the minimum value of x will be, of f of x will be minus 23 upon 6, or we can write it in decimal as minus 3.83.